We're in section 4.7, which is about proof by contradiction and contraposition. So we're going to start with proof by contradiction. And I'm just going to outline how proof by contradiction works. Step 1, you're going to suppose the statement to be proved is false. Step 2, you're going to show that this leads to a contradiction. And step 3, you conclude the statement to be proved is true. So we're going to look at one example of proof by contradiction, and it's the following. Let's prove that there is no greatest integer. So we're going to prove this by contradiction. Start our proof off here. Now remember our steps. Let's go back. Suppose that the statement to be proved is false. So you're going to assume that this statement here is false. You want to assume that that's false. So if it's false, there must be a greatest integer. So when we usually do proofs by contradiction, we start off by saying, suppose, for the sake of contradiction, there is a greatest integer. And let's give it a name. Let's call it capital N. Well, what does it mean to be the greatest integer? It means it's bigger, it's greater than or equal to every other integer. So I'll say then capital N is greater than or equal to little n for every integer n. So remember, our goal is to get a contradiction out of this. And so I need to find another integer that's actually bigger than this capital N. So let's just add 1 to that number. Let's let m, capital M, be n plus 1. M, this capital M, is an integer, y, because it is a sum of integers. And also, m is bigger than capital N, since m is 1 more than capital N. But what do we have now? Let's stop and think about it. M is an integer greater than n. But this contradicts that capital N is the greatest integer. This contradicts that n is the greatest integer. So we've reached our contradiction, which was step 2, and now I make my conclusion. Because I got a contradiction, the original statement must have been true. Therefore, there is no greatest integer. And this completes our proof.